Hey guys, so today we're going to be solving the infamous Leetcode 125 valid palindrome problem. Now, a palindrome is a string which can be spelled the same forwards and backwards. So for example, we have a few examples here, like race car. We can spell this exactly the same backwards. We also have the case of numbers, and we can also write them down as it is backwards. So 1, 2, 3, 2, 1, 1, 2, 3, 2, 1. And then also a much more complex string like this is still considered a palindrome if we allow strings with spaces and commas, and we can just ignore these. So essentially, these are also a valid palindrome given that we ignore the commas and the spaces and all of these other characters which are not alphanumeric. Now, let's look at an example of how we could understand whether a string is a palindrome or not and how we can solve it. Now, we need to understand the concept of a reflected index. Now, a reflected index is basically a specific index and then its reflection. So, for example, we have the word madam. The reflection of the index 0 would be index 4 in this case. And the reflection of index 1 would be 3. And for 2, it would be 2. Now, to calculate the reflective index given at any specific point is really easy. We just need to utilize this formula. So let's say that we are at the first index, the 0 index. And the length of the string is 5. So the reflective index would be 5 minus 1, and this is just to account for 0 indexing, minus the current index you're on right now, gives us the reflected index. So for 0, we should get 4. So let's look at a few examples. I at 0 is equal to 4 minus I, which is itself 4. So the reflective index of 0 is 4. Same for I is equal to 1. So 4 minus I, 4 minus 1, 3. So the reflective index of 1 is 3. And then the same for 2. 4 minus 2 is equal to 2. And then 2 is obviously a reflection of itself. And then let's just say that we go past this midpoint to the index 3. Now in this particular case, 4 minus I is 4 minus 3, which is 1, which essentially is pointing back to itself. However, for our palindrome problem, we only need to iterate up to and before the midpoint. So if we can figure out these two values, then we should be able to get these two values from our reflective index formula. And then using that, we can check if this string is a valid palindrome or not. Now, let's look at the code a little bit. So here is a small function that I have, which is checking for a palindrome. Of course, we're going to fill this out. And I also have a small test file, which has the different test cases and their values. So madam, race car, these strings are all valid palindromes, including an empty string or a spaced string or a string with one character, and these two are non-palindromes. Now, so before we can check a palindrome, we need to clean the string first. As you can see from this particular case, despite being a valid palindrome, the string has spaces and commas, and this will just mess up our reflected index formula that we have created. So to be able to clean our strings, we need to be able to iterate over our strings and essentially create a new clean string. But when we are iterating, we need to check if the current letter or a digit is basically alphanumeric. If this current character is a letter or a digit, this particular function will return true. And again, we are just doing ASCII comparisons, and you can look into the ASCII chart if you're wondering how this comparison is working. And the other functionality we're going to need is that we're going to have to lowercase some of our characters. For example, in this case, 0 and 4 are a reflection, but M is uppercase and this M is lowercase. So we need a way to lowercase our entire string as well. So during comparison, we're not comparing the uppercase and the lowercase characters. Instead, we're comparing the same characters. And the way I calculated the lower string is simply an ASCII increment of 32. So in terms of Go, we're using rune, which is an int 32. And we're just adding 32 to it, and this basically converts any capital character to a lowercase character. Again, if you're not sure how this is working, look into the ASCII chart and see how adding 32 to its integer representation, leads us to the integer representation of a lowercase a. Now, moving on, we need to first check, is this a letter or a digit? Again, if it's a space or a comma or exclamation mark or a question mark, we'll simply skip it. And if it is a letter or a digit, we will save the string and append it to our clean string. Now, after this, our next operation is to calculate the midpoint of that specific string. Again, we just want to iterate with the midpoint, because once we are up, till, and before the midpoint, we can use our formula to calculate the reflective index. So now we have a for loop which is iterating over our till the midpoint, just before the midpoint, as we don't need to account for this centered value. As the centered value itself always will be a reflection of itself. And then using the same formula, we have the reflected index, length of the clean string, -1 to account for 0 indexing, and this entire string -I to give us the reflective index. Once we do that, we can do a very simple comparison. If the clean string at I is not equal to its reflection, then we simply return false. So this would be a case like this, where M might be something like a B. So this is not equal, and therefore it would be false and return false. There's not a palindrome. Otherwise, we will continue our iteration, and if you make it through up till the midpoint, that means that we do have a valid palindrome string, and then we'll just return true. Now, to quickly test this, I will run go test just to confirm that our function is working. And we can see that all our test cases are passing. So this is how you check a valid palindrome in Go.